So the first thing that we're going to do is we're going to look at seeing if if theta equals pi over 4 is a solution. So how we're going to do that is we're going to look at sine of theta, and we're going to plug in pi over 4 into that and solve. And so when I do that, I get 2 sine of pi over 4 minus 1 equals 0. So I know what sine of pi over 4 is. I know that it's 1 over root 2. And so when I have that, I will have 2 minus 1 equals 0. So when I multiply this, I get 2 over root 2 minus 1 equals 0. And I can already tell that this isn't going to go away. 2 over root 2 is subtracted by 1 will not get me 0 because 2 over root 2 is not 1. And so we know that pi over 4 is not a solution to that equation that we had above. So why don't you go ahead and pause the video and try to see if theta equals pi over 6 is the solution. Okay, so to do that, I'm going to take pi over 6 and substitute it in. So 2 sine of pi over 6 minus 1 equals 0. I know that the sine of pi over 6 is 1/2. And so now when I multiply 2 times 1/2 is 2 over 2 minus 1 equals 0. So 1 minus 1 does in fact equal 0. So pi over 6 is an equation, is a solution to this equation. And how I'm getting these values is I'm using my unit circle to help me, and we're going to use it a lot to kind of make sure that we're getting what we need. Okay, so now we're going to solve and find all values of a trig equation. So before we just tested to see if one was a solution, now we're going to find all of them. So our inverse trig rules are going to kind of step to the side, and we're going to use our unit circle in its entirety. So we're not going to restrict to certain quadrants. So when I look at cosine of theta equals 1/2, I can think to myself, where does that happen? Well, cosine is positive in quadrants 1 and 4, so I know that cosine has to be 1/2 at pi over 3 and 5 pi over 3. And so I know that I can do infinite revolutions all the way around. So that would be adding 2 pi to pi over 3. I could do it to 5 pi over 3. And so at the end of the day, we know that we're taking for our infinite solutions is we're taking pi over 3 and we're either adding or subtracting infinite revolutions. And how we express infinite revolutions would be 2 pi. K. So the 2 pi is 1 revolution, and k, remember k is any integer. And so I can just add or subtract as many revolutions as I want to pi over 3. And so I would get pi over 3 plus 2 pi k. And that would be one way to express all of our solutions for this spot. But I also have to remember the 5 pi over 3. So if theta is equal to 5 pi over 3 plus or minus our infinite revolutions, then all I have to do now is add to this theta is equal to 5 pi over 3 plus 2 pi k. And so those are my formulas for infinite or general formulas. So we can find any value at any time when cosine is equal to 1/2. And again, k is any integer. So when I want to list 8 of the solutions, all I have to do is add or subtract 2 pi to pi over 3. And then if I want more, I can add or subtract 4 pi. And I can just keep going. So when we first start with pi over 3, and I add 2 pi, an easier way to think about that is to put them in common denominators. So that's like taking pi over 3 plus 6 pi over 3 and yielding 7 pi over 3. So here's one solution, here's 2 solutions. And so I really just need to find 2 more with pi over 3. So I could take pi over 3 and add 12 pi over 3, or whatever you want, right? That would be adding 4 pi. Or I can just take this and add 6 pi over 3. And so that would give me 13 pi over 3. So that would be another solution. I could also take pi over 3 and subtract 2 pi, which would be taking pi over 3 and subtracting 6 pi over 3. And so that would be giving me negative 5 pi over 3. So there would be 4 solutions. So, and that's all looking at pi over 3 as our terminal ending point. So why don't you try it with 5 pi over 3? So 5 pi over 3, if I add 6 pi over 3, I get 11 pi over 3. So there's one solution, two solution. We add another 6 pi over 3, giving me 17 pi over 3. And then I could take 5 pi over 3 and subtract 6 pi over 3, giving me negative pi over 3. So I do have 8 solutions here, and it's just a coincidence that when I subtract 2 pi from the other one, I got these values but negative. And so that won't always happen. So our 8 solutions here would be pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, 13 pi over 3, I'm just putting them in order, 17 pi over 3, and we even have negative pi over 3 and negative 5 pi over 3. So all of these are the first 8 solutions. Okay, so now we're going to look at solving a trig equation, and we have 3 examples here. The first one is 2 sine theta plus root 3 equals 0. So what I'm trying to do here is find all values of theta that are between 0 and 2 pi that make this equation true. So when I do that, I look at my equation. So again, that's 2 sine of theta plus root 3 equals 0. So I want to isolate sine of theta. And once I've done that, then I can go ahead and figure out what is theta at that time. So to do that, I have to subtract root 3 from both sides. So I have 2 sine of theta equals negative root 3. And then I can divide by 2, and I'm left with sine of theta is negative root 3 over 2. So we can think about where that occurs. So sine is negative in quadrants 3 and 4. So for sine to be negative, I'd have to be at 4 pi over 3, or I have to be at 5 pi over 3. And so if I'm looking for the general form, which it didn't ask for, but if I needed it, the general form would be taking theta and saying that it's equal to 4 pi over 3 plus 2 pi k. And theta would also be equal to 5 pi over 3 plus 2 pi k. And then I could add or subtract 2 pi as many times as I needed to, and ultimately get my 8 solutions or whatever I needed. Now, this is saying I have to be super restrictive between 0 and 2 pi. And so to be between 0 and 2 pi, I know that if I add a whole nother revolution, I'm going to pass 2 pi. So the only answers here are 4 pi over 3 and 5 pi over 3. So there are no other answers between 0 and 2 pi. And that's it. Now things change a little when we have something like 2 theta on the inside. And so what I do is I substitute for 2 theta is I'll take x and set it equal to 2 theta to make my life a little bit easier. So I'm really looking at the sine of x is equal to 1/2. And I know where sine of an angle is equal to 1/2. That's at pi over 6 and 5 pi over 6. So when we're looking at our general form, notice how we had a theta here, and so we put theta on this side, we put the angle, and then plus 2 pi k. We're going to do the same thing, except we're not going to use just theta. We're going to use x to start. So x would be equal to pi over 6 plus 2 pi k, and x would be equal to 5 pi over 6 plus 2 pi k. Now our general form needs to have theta equals, and so we had x being 2 theta. So if I include 2 theta and substitute that in, I get 2 theta equals pi over 6 plus 2 pi k, and 2 theta equals 5 pi over 6 plus 2 pi k. Now, in order for me to get my general form, I need to have theta equals. So on both sides of the equal sign, I'm going to multiply by 1/2. And when I multiply by 1/2, what'll end up happening is these will go away because they'll cancel each other out. So theta would be equal to, And then this 1/2 is distributed to both pieces. So I would have pi over 6 times 1/2 and plus 2 pi k times 1/2. So pi over 6 times 1/2, that's going to become pi over 12. And then over here, these two cancel, and so you're left with just pi k. And the same thing is going to happen over here. I get theta equals 5 pi over 6 times 1/2 plus 2 pi k times 1/2. So this theta would be 5 pi over 12 plus these 2's go away, and you're left with pi k. So now what we can look at is I need to be between 0 and 2 pi. And so if I think about where pi over 12 is and 5 pi over 12 is, they're both, here's about pi over 12, and then here's about 5 pi over 12. And I know 5 pi over 12 is in quadrant 1 because straight up would be pi over 2 or 6 pi over 12. So I know that they both have to be in quadrant 1. And now we know what's happening here. This 2 theta, what's happening here in terms of our graph is that this is affecting the period. And so our period is now pi. So I would have to fit everything into pi, but I want to know where the next would go, the next 2 values would be, because we can fit 1 whole period in pi, and so I can fit 2 whole periods in 2 pi. So what I want to do is figure out where these other values are, and so I can actually just off to the side say when k equals 0, when k equals 1, or you can think about if theta, right, was equal to pi over 12, well, that's an answer to start, and then I'm adding 2 pi, or just pi, not 2 pi. And so that's going to give me pi over 12 plus 12 pi over 12, which is 13 pi over 12. And so there's another answer. And I know that that one is 12 pi over 12 away. So I'm in quadrant 3. If I were to add another pi to it, I would end right over here. And so that would be more than 2 pi. So I know that I have to stop there with pi over 12. And the same thing with 5 pi over 12. We can add pi. So 5 pi over 12 plus 12 pi over 12 is equal to 17 pi over 12. And so I know where I was for 5 pi over 12. If I add a pi, now I'm down here at 17 pi over 12. If I add another pi, I'm just going to be at a new name of this place, which is beyond 2 pi. So my answers here would be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And so I would have 4 answers for this one. Now for this last one, we can look inside, and this is actually not affecting the period, but it's a phase shift. And so this one would be a horizontal shift to the right pi over 12. So if you think about what's happening graphically, where our normal tangent was something like this, now it's being shifted to, so this is our asymptote, to something like this. So where we used to have asymptotes at pi over 2 and negative pi over 2, now they're at 0 and pi. And so what our answers used to be are now being shifted to the right pi over 2. So our values will change. So when I look at this, I'm going to also substitute x for theta minus pi over 2 and solve it the same way that I did above, except instead of multiplying by 1/2, I'm just going to have to subtract something or add something. So I'm really looking here when tangent of x is equal to 1. So if I think about on my graph, tangent's positive in 1 and 3, I have to have the same 2 values. So that would be here at pi over 4, and it would be here at 5 pi over 4. So when I go and set this up, x would be equal to pi over 4 plus 2 pi k for a full revolution. I also have that x is equal to 5 pi over 4 plus 2 pi k. But another thing to note is that if you recognize that these are just pi apart, You could write it as one thing and say theta is equal to pi over 4 plus pi k. However, I don't love that method, or not theta, it'd be x, because when I think about this, this is the only one that comes off the top of my head that are pi apart. Everything else, as we saw, are not. They don't have a relationship, and so I like to think about them separately. I still get the same answer if I think about them separately. So I know that x was theta minus pi over 2, and that's going to equal pi over 4 plus 2 pi k. And theta minus pi over 2 equals 5 pi over 4 plus 2 pi k. So when I add pi over 2 to the other side, I can only combine like terms. And so pi over 4 and pi over 2, neither of them have a k in them, whereas the other one has a k. So I can't add it to the one that has a k. And then the same thing is true here. I have 5 pi over 4 plus 2 pi k plus pi over 2. And so I'm only going to add like terms. And then an important thing to remember is that pi over 2 is equal to 2 pi over 4. So now when they have common denominators, I can easily add them together. So theta would be equal to 3 pi over 4 plus 2 pi k. And then over here, we have 2 pi over 4 for this, so I would have 7 pi over 4 plus 2 pi k. And so now I have my two general forms, so now I can be specific between 0 and 2 pi. However, I know that these two, 3 pi over 4 is here in quadrant 2, and 7 pi over 4 is down here, and so if I add a full revolution to either of those, I'm going to be beyond 2 pi. So theta would have to only equal 3 pi over 4 and 7 pi over 4. However, if you were to ask to find the 8 solutions or so, that's when you would just add or subtract 2 pi. All right, and that's it.